The Airbus A320 is one of the most successful jets in history, but even legends can't last forever. In this video, we uncover how Airbus's next-generation aircraft, designed to succeed the legendary A320, aims to redefine efficiency, passenger comfort, and modern aviation. With airlines like Lufthansa, EasyJet, and American Airlines closely monitoring the program, expectations are sky-high for a jet that can carry the A320's legacy forward. Yet years of engineering challenges, ambitious sustainability goals, and the pressure to meet evolving market demands have raised questions about its future. Once seen as the inevitable successor to one of aviation's most successful jets, this aircraft now stands at a crossroads. Will it deliver on Airbus's bold vision or face unexpected setbacks? Stay tuned to find out. To understand why Airbus is planning to replace the legendary A320, we first need to look at its origins. Introduced in the 1980s, the Airbus A320 family transformed commercial aviation. It was the first commercial aircraft to feature a fully digital fly-by-wire control system, replacing traditional mechanical controls with electronic interfaces. This innovation reduced pilot workload, improved fuel efficiency, and set a new benchmark for safety and performance. But that's not all. The A320 family includes several variants designed for different market needs. The A318 is the smallest, seating 107 to 132 passengers, while the A319 offers a slightly larger capacity of 124 to 156 seats. The standard A320 accommodates 150 to 186 passengers, and the A321 is the largest, seating between 185 and 230 passengers. All these variants share a common fuselage design, which allows airlines to operate multiple models with similar training requirements and maintenance procedures. Since its first flight in 1987, the A320 family has become the best-selling airliner series in history. By mid-2025, over 12,000 units had been delivered to more than 350 operators worldwide, including carriers like Lufthansa, EasyJet, and American Airlines. In 2016, Airbus introduced the A320neo, featuring more fuel-efficient engines and aerodynamic improvements like sharklets. These upgrades have improved fuel efficiency by up to 15%, helping airlines reduce operating costs and environmental impact. The A320's design also emphasizes passenger comfort. Wider cabins, modern seating layouts, and quieter engines set a standard for short and medium-haul flights. Over the decades, the A320 has earned a reputation for reliability, operational flexibility, and economic efficiency, making it a backbone for airlines around the world. Even with this success, Airbus recognizes the need to innovate. Global airline demands are shifting, environmental regulations are tightening, and new technologies are emerging. That's why Airbus is quietly developing a next-generation aircraft to succeed the A320. This new jet aims to combine advanced aerodynamics, state-of-the-art propulsion, and sustainable design, ensuring it can carry the legacy of the A320 into the future while meeting modern challenges. Interesting, right? Now let's dig deeper. Liking the story so far? Keep watching, because next we'll explore the development of Airbus's next-generation aircraft, its ambitious technology, and the challenges Airbus faces in creating a worthy successor to the A320. While the A320 family has been a cornerstone of modern aviation, Airbus is already looking ahead. The company is developing a next-generation aircraft that promises to redefine efficiency, technology, and passenger experience. This new jet aims to succeed the A320, combining cutting-edge aerodynamics, advanced propulsion systems, and sustainable design to meet the demands of modern airlines and environmental regulations. Airlines that built their fleets around the A320, like Lufthansa, EasyJet, and American Airlines, are watching closely, eager for a plane that can carry the legacy forward. But innovation comes with challenges. Can Airbus deliver a worthy successor, or will the road to the skies prove more turbulent than expected? Tighten your seatbelts, this is about to be an interesting ride. The A320's legacy is unmatched, but Airbus's next-generation aircraft aims to rewrite the rules of modern aviation. At Airbus's 2025 summit in Toulouse, the company unveiled its long-term vision for a next-generation single-aisle aircraft aimed to replace the A320 family. This future jet is planned for entry into service in the second half of the 2030s, a strategic window that balances necessary technology maturity with market readiness. What's more, Airbus executives stressed this is not a rushed project. Bruno Fichefeu, head of future programs, explained, "We are taking the best of what we've done and preparing for another jump when the time is right." Meanwhile, CEO Guillaume Faury emphasized the aircraft will represent a pivotal generation, bridging the traditional aircraft era with burgeoning hydrogen technologies. The plan relies on modular or technology bricks, rather than a fully developed aircraft today. Airbus is investing in cutting-edge elements like ultra-efficient engines, innovative wings, and digital systems that can be validated independently before being combined in a finalized design. This stepwise approach gives Airbus flexibility. If an open-fan engine design proves viable, it can be integrated. If not, alternative technologies remain available. From a market perspective, Airbus is optimistic but cautious. Despite the A320 family's success, including over 4,000 A320neos delivered and more than 11,000 orders in 2025, the narrow-body market remains fragile. Boeing is rebuilding its position, and emerging entrants like Comac and Embraer pose new threats, especially in Asia. Airbus must diversify and innovate, not only to defend its market share, but to lead the next era of air travel. Strategic timing plays a critical role. Airbus doesn't plan to rush into a full launch before key technologies prove their worth. It's also worth noting the dual-path development strategy. Airbus is keeping one path conventional, enhancing fuel efficiency by 20 to 30%, and enabling a high SAF capability, while also advancing hydrogen technologies in parallel, though with a more cautious timeline. This dual track allows Airbus to hedge risks while keeping long-term sustainability goals in play. In essence, Airbus's roadmap is smartly phased. Explore and validate technologies now, wait for the right moment, then combine the most promising innovations into a successor jet that meets future needs. Whether it's for efficiency, sustainability, or simply market leadership, Airbus is positioning itself to remain at aviation's cutting edge. You're probably already curious about the engine. Buckle up, because this section dives into one of the most exciting and game-changing frontiers in Airbus's next-gen aircraft, the engine. Airbus is teaming up with CFM International under their Revolutionary Innovation for Sustainable Engines program to test something radically different, the open fan engine. Picture jet blades fully exposed, spinning freely at the front. Yes, you'd actually see them mid-flight. It looks futuristic because it is. And it's not just eye candy. This bold design promises more than 20% fuel burn savings compared to today's most advanced engines. In aviation terms, that's not incremental progress, it's a revolution. So, how does it work? The secret lies in the bypass ratio. In a conventional jet engine, air splits into two streams. Some goes through the core to burn fuel, while most bypasses around the outside, creating efficient thrust. The higher the bypass ratio, the better the efficiency. Open fan technology cranks that ratio up dramatically, moving more air around the engine instead of through it. Less fuel, more thrust, that's the magic. Airbus and CFM aren't just sketching this on a whiteboard. They've been running wind tunnel tests to refine aerodynamics, noise behavior, and installation. Hundreds of hours of data have already been collected, and the next big step is flight testing on a modified A380 testbed later this decade. That's when we'll see if this engine can really deliver outside of simulations and models. But innovation comes with roadblocks. First up, noise compliance. Without a casing, the open fan produces a different acoustic signature. Engineers say it isn't necessarily louder, just different, but regulators and airports will need convincing. Then comes certification. Proving to authorities that a new engine concept meets safety standards is no easy feat. And finally, there's integration. Marrying this unconventional engine to an airframe without introducing drag or handling quirks is a high-stakes puzzle. Meanwhile, the competition isn't sitting still. Pratt & Whitney is doubling down on its geared turbofan, which already flies on the A320neo. Rolls-Royce is pushing its ultrafan concept, a geared design scaled for narrow bodies that could also deliver double-digit efficiency gains. These alternatives look less radical, but they have the advantage of familiarity with regulators and airlines alike. So Airbus finds finds itself at a crossroads. Pursue the open fan and potentially leapfrog Boeing and others, or hedge bets with safer evolutionary propulsion tech. As Airbus CEO Guillaume Faury put it, the open fan is quite revolutionary, but revolution means nothing if it can't be certified, scaled, and trusted by airlines. The burning question is clear: will these engines be ready in time to power the A320's successor? Or will Airbus have to play it safe? Time will tell. When it comes to building the next generation of aircraft, wings are often the defining factor. Airbus is betting big on its Wing of Tomorrow program, a project that reimagines how wings should look, perform, and function in the skies of the future. The idea is simple in principle, but complex in execution. Longer, thinner, and lighter wings that maximize aerodynamic efficiency, cut drag, and save fuel. On paper, it sounds like the perfect upgrade. In reality, every design breakthrough comes with technical and operational hurdles. Let's look into them one by one. The longer the wing, the better the fuel economy, thanks to reduced drag. Airbus has been testing composite materials and advanced manufacturing techniques that allow wings to be built lighter without sacrificing strength. However, a longer wingspan raises immediate questions about where these aircraft will actually fit. Current airport infrastructure, taxiways, gates, and hangars was designed around today's aircraft sizes. If Airbus stretches the wing too far, airlines could face costly logistical headaches just trying to park or maneuver planes at busy hubs. This is where foldable wingtips enter the conversation. Borrowing inspiration from Boeing's 777X, which debuted folding tips to squeeze into standard gates, Airbus is exploring a similar concept. The appeal is clear. Enjoy the efficiency of a longer wing in the air while folding it neatly on the ground to fit within existing airport boundaries. Yet, while elegant in theory, the design raises concerns over safety and reliability. Folding mechanisms add complexity, increase weight, and introduce potential failure points. For airlines, reliability is non-negotiable. If a folding tip jams, fails mid-flight, or even requires more frequent maintenance, the supposed benefits could quickly turn into operational nightmares. Weight management is another delicate balance. A wing designed for maximum efficiency must also support advanced folding systems without becoming too heavy. Airbus engineers face the challenge of integrating composites, hydraulics, and locking systems without offsetting the gains in fuel burn. It is a fine line. Build it too heavy, and efficiency evaporates. Build it too light, and questions about durability and safety come to the forefront. The issue goes beyond engineering. For airports and regulators, safety certification of foldable wings will be crucial. Boeing has already set a precedent with the 777X, but Airbus will need to prove that its design is equally dependable and compliant with strict aviation standards. At stake is not just technology, but trust. Passengers and airlines alike must believe that these wings are as safe as they are efficient. So the pressing question remains: can Airbus deliver cutting-edge aerodynamic gains without creating operational headaches for airlines? The promise of tomorrow's wing is undeniable: sleeker, smarter, and greener. But unless Airbus can balance innovation with practicality, even the most futuristic design risks being grounded by the very realities of today's aviation world. As Airbus looks ahead, it's clear the eco-challenge isn't just about cleaner engines or smarter wings. It's a test of balancing short-term progress with long-term transformation. Enter two critical pillars: 100% SAF capability as a bridge today, and the ambitious but delayed hydrogen ZEROE future. Let's start with sustainable aviation fuel SAF. Airbus is aiming for all its new single-aisle aircraft, including the A320 successor, to be capable of flying on 100% SAF by 2030. That's a huge leap from today, where most aircraft can only handle up to a 50% SAF blend. SAF, typically produced from bio-based or synthetic sources, can cut lifecycle CO2 emissions by up to 80%, making it one of aviation's most viable decarbonization tools right now. But life isn't that easy. SAF remains costly and rare. Currently, it accounts for just a tiny fraction of total jet fuel, and scaling production demands massive investment across the supply chain. That said, as Airbus embeds 100% SAF compatibility into its designs, it empowers airlines to start decarbonizing immediately. No waiting for new planes. Meanwhile, Airbus's long-term vision rests on its Zero-E hydrogen aircraft concepts. Launched in 2020, Zero aimed to deliver a zero-emission commercial jet by 2035 using hydrogen combustion or fuel cells to power innovative airframes. Unfortunately, the world hasn't caught up fast enough. The hydrogen economy, production, green supply, airport infrastructure, regulations is years behind where Airbus hoped. Reports now suggest the Zero program may be suspended or delayed by up to a decade, shifting commercial deployment to the year 2040. Budget cuts and halted flight testing on modified A380 demonstrators have also been reported. So here's where Airbus finds itself, caught between two worlds. On one side, regulators, airlines, and climate targets all demand decisive action now. The world can't wait until the 2040s to decarbonize aviation. On the other, hydrogen remains the only scalable path to full zero emissions in the longer term. Airbus calls this next-gen single-aisle the pivotal generation, a bridge between conventional aircraft and hydrogen-powered flight. That means designing SAF-ready planes that can serve the market now, while also investing in hydrogen development that may yet pay off decades from now. It's a high-wire act. Can Airbus juggle both, making SAF-powered planes available in the near term and still advancing hydrogen systems for the long haul? Investors, regulators, and climate advocates will be watching closely. The success of this dual-track strategy hinges on keeping SAF adoption scalable and affordable, even as hydrogen technologies continue to mature. For Airbus, the sustainability debate is no longer just an engineering challenge, it's a balancing act between today's demands and tomorrow's promises. On one side, SAF is the immediate answer, already compatible with existing fleets and backed by regulators pushing for quick wins. On the other, hydrogen remains the bold dream, the game changer that could rewrite aviation's future but lingers years behind schedule. Airbus's Zero-E program carries the weight of expectation, yet timelines keep slipping and skepticism grows. This generation of aircraft may not be hydrogen-powered, but it is the generation that decides whether the transition is real or rhetorical. The pressure isn't just technical, it's political, economic, and environmental all at once. Airbus has positioned itself as the pioneer of cleaner skies, but the gamble is clear. Can it deliver SAF today without losing the hydrogen race tomorrow? The answer will shape not just Airbus, but aviation itself. Some aircraft mark the past, others set the course for the future. For Airbus, this isn't just about designing airplanes, it's about deciding what flying will look like for the next century. Will the industry settle for incremental progress with SAF, or leap into a hydrogen revolution that demands reinvention from the ground up? These are the crossroads where aviation's biggest gambles are made. That's why we share these stories, because behind every sleek design and bold promise lies a struggle with time, technology, and ambition. If you enjoyed this deep dive, subscribe and join us as we uncover the jets shaping tomorrow. From forgotten experiments to revolutionary concepts, we'll keep telling the stories that matter. And if there's an aircraft you want us to explore, let us know in the comments. We read every single one. Your idea might be our next takeoff.